Hey guys, in this video we're going to be taking a look at polynomial operations, more specifically adding and subtracting polynomials and multiplying them. So in this first problem it says subtract 4x squared minus 3x plus 9 from 7x squared plus 8x minus 3. Now seemingly this seems like a pretty straightforward problem. However, this word right here, from, is actually going to throw a curveball in before we even get started. As we've seen in class, by phrasing it like this, we're actually going to start with the second polynomial first. So I'm going to kind of write a math sentence to translate what the question is saying. It's saying we're starting with the 7x squared, okay, because we're taking away something from it. So even though the order is the exact opposite, we're going to write it like this. And there's one thing that my math sentence, my expression, whatever you like to call it, is missing right now, is parentheses, right? Think about what I have written down right now. Am I really subtracting that first polynomial of 4x squared? All I'm really taking away is the 4x squared. Everything else stayed the exact same. So when I add parentheses in here, it kind of does that for me. Hey, now I'm subtracting the whole thing. So before we start matching up like terms, we want to distribute that negative. Distributing a negative is very simple. Basically, everybody's sign inside the parentheses is going to change. So it's going to become minus 4x squared plus 3x minus 9. Okay, now we match up our like terms. If we want to write our answer in standard or simplest form, which is traditionally what we do, we start with the highest exponent first. So for my x squareds, you always want to pay attention to the sign in front. So notice my kind of underlining or whatever shape or whatever you're looking at it, make sure you're paying attention to the sign in front, that negative in front of the 4, really subtract 4. I'm treating it like a negative 4 when I combine them. So now I can say, hey, 7 minus 4 is going to give me 3x squared. Okay, for x, I have 8 and 3 both positive, so that's simply going to be 11. And then for my constant terms, those are the terms without any variables. Be careful here, negative 3 minus 9. Or this is something you type in your graphing calculator if you just want to double check. That's minus 12. Okay, and reflecting upon our answer real quick, it's in standard form. We've simplified or combined everything we can, multiplied everything, and it goes in decreasing or descending exponent order. We start with the highest exponent and work our way down. Usually if there is a constant, that's what will come last. Okay, more specifically with our answer, we say it's a second degree polynomial because the highest exponent is 2. Whatever the highest exponent, that's the degree. Some other words we have here, 3 we can refer to as our lead coefficient, and 11 is another coefficient in there. And like I mentioned earlier, the minus 12 on the end here, or the negative 12, we call a constant. Just some vocabulary to be familiar with because these terms do pop up in various other questions. All right, and in this one we're going to be taking a look at something a little bit more complicated. We're going to simplify an expression where we see a binomial being squared. We got some combining like terms to do once again. And then a little like part A question here. Once we get our answer, whatever the result is, we're going to multiply it by 1/2 x squared. So the first thing that kind of grabs our attention is this right here. Okay, the 3x minus 2 squared. Your gut instinct might be to first distribute the 5. You know, whenever you see a number outside parentheses, you just want to kind of jump in and say, all right, 15x minus 10. However, if we think back to our order of operation rules, we have to kind of satisfy this exponent. We have to deal with this exponent before we can deal with any multiplication. And another common mistake that people make when they see a binomial squared, they just simply square both terms inside of it. You either put a minus 4 or a plus 4. In either case, they're both wrong. Okay? You can't use that shortcut of just squaring everything inside like we usually do with our power rule. That only works for terms that are being multiplied together. In this case, we have a difference of terms. And what kind of really leads you into what you should do, not saying you have to write this out every time once you recognize it, it's really thinking about what squared means in this case. Okay, 3x minus 2 squared really means 3x minus 2 times 3x minus 2. And once you write it out like that, you're going to see, oh, really, this is a box method question kind of in disguise. At this stage, you can distribute the 5. Now everything's being multiplied, right? We don't have an exponent there. You can distribute the 5 to one of them and treat it as 15x minus 10. It's perfectly fine. I like to kind of save it off on the side just to make my box method a little bit easier to work with. So let's figure out what our trinomial is going to be. So we're going to set up a 2 by 2 box of 3x minus 2 and 3x minus 2. Remember to figure out what goes inside each one. Notice I did put the minus sign, the negative sign in front of the 2 to remind myself when I'm multiplying. And to figure out what goes inside, we're multiplying what's on top with what's on the left. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. We have another one down here and a positive 4. Okay, we can combine these. Be careful. They don't cancel out. That would be negative and positive 6. These are going to be negative 12 when we combine them. So like I mentioned earlier, at this stage we could distribute the 5. So if you did it in the beginning, you did it in the end, it doesn't really make any difference. I like to usually do it on the end just so my box isn't that crazy. It doesn't have larger numbers. Okay, I distribute the 5 to all 3 terms inside. And now I can play my like term game like we learned on the previous slide. I'm running out of room here. Okay, we start with our x squareds. I'm move my answer. I guess I could write it down below. 45 minus 5 is 40x squared. Once again, pay close attention to the sign. It's not being treated as a positive 5. With my x's, I have negative 60 and positive 3. So that's going to be negative 57 x. And with my constant terms, I have 20 minus 11, which is positive 9. Okay? And now it says multiply this by 1/2 x squared. So it's basically kind of saying this. Take it and kind of set up a distribution problem. It's a 40 minus 57x plus 9. Okay, so if we multiply the first, half of 40 is 20. And what's x squared times x squared? X to the 4th. Okay, some of these answers are going to be a little ugly here. 1/2 times 57 is, what is that, 28.5. You could leave it as 57 over 2 or something like that, which I will. I don't usually put decimals with polynomials. And now x squared times, really what's there in x to the 1st? Remember we add exponents, so it should be x to the 3rd or x cubed. And our last product here, 9 times 1/2. Once again, I'm just going to leave it as 9 over 2. X squared. Nothing to combine there, but the x squared kind of glues on. And that's our final product. Once again, standard form. This one we would refer to as being in the 4th degree, lead coefficient of 20. Standard form because the exponents descend. They work their way down, starting with the largest. So this problem featured a lot of different operations taking place. Be comfortable with knowing how to multiply using the box method. Be careful when combining like terms, both in the box method and otherwise. Okay, take a second to match up using different shapes and things like that, or starting with the highest, just so you're not doing it randomly and losing your place. All good tips to help you get the correct answer. Thank you guys for watching, and hopefully this helped with polynomials.